Alright, in this tutorial we are going to be learning how to program our robot to drive. So, very first thing we need to get started is an Arduino create account. We should have gone over that in the last tutorial. You'll need a computer with an Arduino plugin installed into the browser. When you sign up for the account, it walks you through how to do that. And you also need your assembled base robot. You should have 2 motors plugged into it at this point and nothing else. So, before we get started, when your robot drives, if it runs into things like a wall or a chair, it's going to damage the motors. So as soon as it hits something, you need to pick it up. When your motor starts to break, you're going to hear a clicking sound. That's the gears inside of the motor wearing down because the motor wants to go and the wheel wants to go, but the robot can't move because it's stuck and it's hitting something. So please pick it up as soon as it runs into something. It'll save you a lot of headache. Alright, so let's get started. So the very first thing we're going to do, we are going to go to the Arduino Create web editor and we're going to find the example library. So the first thing we do is we're going to click on libraries. We're going to type in MOREbot as soon as we give it a second to load. So you'll type in MOREbot, search it, it should be the first thing that comes up, MOREbot library. You're going to click on this examples thing right here and you're going to pick the first program. It's called MOREbot Drive. So once we click on that, we should have this code pop up right here. It should look the exact same. So once you're at that point, the next thing we're going to do is actually plug in our Arduino and upload that code. So I'm going to upload mine now. Go back to here. So you see there's no board here, but once I plug in my robot, it will say it's connected. There we go. So you just click your upload button. Should verify the program that it works. It's going to tell you that it's uploading, and then done. So now that it's uploaded, what I need you to do is upload your code and see what happens. Now what should have happened is your robot should drive forward for about a second and then stop. Now when you upload this code, my suggestion is to unplug your Arduino or unplug the cable and put it over your robot. Set the robot on the ground and plug in your robot and then let it go. So, if your robot went forward, everything is good. If your robot did not go forward, I would suggest looking at your motor wires. So one of probably 3 things happened. If it did not move at all, check to make sure that you actually uploaded the code. If it just spun, what you need to do is look at the wheel that's spinning in the wrong direction. If the robot is going forward, and it's supposed to go forward and it spun, that means one of the wheels is not turning the right way. So find out which wheel that is, and then switch your 2 motor wires. You should have a red and a black motor wire. The black motor wire should always be on the inside, closest to the ground pin. The red one should be on the outside. And if your robot went backwards, you need to flip both of your motor wires around. Okay, so let's assume at this point you fixed your robot, or your robot's working, and your robot went straight. Let's see if we can change some things. How do we make it go forward? So, go forward for longer. So what we're going to do is change the delay statement in our code right here from 1000 to, let's call it 2000. So when you try to make a change, you'll notice it'll pop up something that says, hey, you need to save this to your sketchbook. That's because you're editing an example. So you're just going to go ahead and click OK, and everything will be fine. So now it's 2000, and I'm going to click my upload arrow. It's going to upload. Alright, now that it's done, you need to unplug your robot, set it on the ground, and test it. So, what happened? Well, your robot should have gone forward for about 2 seconds now. So what is this delay thing that we just changed? Well, basically, the delay line, or command, stops the program, tells it to do the thing above it for a certain amount of time. So, for example, right here we're saying delay 2000, and it made the robot go forward for 2 seconds. Now, why did it not go forward for 2000 seconds? Well, the reason is delay is in milliseconds. So 1000 milliseconds is actually 1 second. So if I typed in 500, any guesses as to how many seconds that would be? It'd be half a second. If I typed in 1500, it'd be 1.5 seconds. In general, when you're programming with your robot, when you're doing things like turns, if you want it to go, say, 90 degrees or 45 degrees, typically your delay will be less than 1,000 seconds. The longer the robot goes, the more likely it can get off path. Okay, so now we've got a little bit of an idea of what delay does for us. Let's find out another way to make it go forward farther. So now what we need to do is change delay back to delay 1000 and change bot.forward to bot.forward 100. So this is already 1000 again. I'm going to type 100 right here and get that out of the way. So once you do that, go ahead and upload the code to your robot and see what happens. So when you test this on your robot, what should happen is your robot goes just a little bit farther and just a little bit faster. That's because this number right here is actually the speed that we want the robot to go. So this is on a percentage. So it's not just 100 units, it's 100% of the max speed. So if I say bot.forward 0, it's not going to go forward at all, actually, because 0% of the max speed is just 0. But if I tell it to go forward 50, it's going to go forward at half speed. So the key things that you remember here are that you've got your parentheses and your semicolon, and in between there is a number. Now, what would not work is if you did 100.5. So that won't work. So always keep it a round number. For example, 1, 2, 3. And typically with driving the robot, it's a lot easier for the robot to move if you make the speed above like 20 or 15. When it gets really low, it sometimes becomes hard for the robot to overcome the friction fighting it to move. But also when you keep it going really fast like this, it's harder to be precise, and it's harder to catch your robot in case it runs into things. When you start going above half speed, you really got to watch your robot and make sure it doesn't run into things. So next, let's talk about all the different commands we can use. So if there's bot.forward, it makes sense that there are things like bot.backward, bot.right, and bot.left. Now there's one thing that I haven't showed you yet, and that's bot.stop, but we're going to get into that in a minute. So for now, let's break down what a driving command actually contains. You need to have two lines, bot.forward and and just delay. And there's three key elements here. There's the direction, the speed, and the time for it to go that direction and speed. Of our directions, remember there's forward, backwards, left, and right. And for speed, it can be 0 to 100. Now make sure you always have these semicolons at the end. They basically tell the robot you're done with your instruction. If you forget those, you'll get an error message. And remember, when the robot reads code, it's reading it like you would a recipe. So it goes line by line. So it's going to read this first line. That's just setting the robot up. You don't have to worry about that one. But then the second line is saying, hey, go forward and do it for 1 second. And then after it does that for 1 second, the program hangs up here for 1 second. And then it reads the next line. It says bot.stop. It ignores any white space and just goes line by line. So it's really looking at these semicolons. So don't forget them. So now that we got that, let's talk about bot.stop. So bot.stop was the thing that is at the end of this line right here, bot.stop. But next, we're going to delete that. So let's see what happens when we delete that. So we're going to delete that, upload our code, and go ahead and set your robot on the ground for this one. So, what happens? Well, your robot probably didn't stop moving. It went forward at 100% speed, but then it just kept going. But that doesn't make any sense, right? Because we told it to stop, or to only do it for 1 second. Well, what's happening here is bot.stop is similar to bot.forward in that it tells it something new to do. But after the delay, we never told the robot to do anything else. So in the robot's mind, it should be going forward, and the delay just kind of holds the program up before the next instruction. It doesn't tell it to go forward for 1,000, it just says, hey, don't do the next thing for 1,000 seconds. So once you add that bot.stop, the next line it reads after 1,000 milliseconds is bot.stop, so it's going to stop. But if you delete that, it's just not going to stop. Now, this bot.stop doesn't have to be at the end of your program. You could have it stop, wait for a second, say a second. And then we could have it go forward again. Or we can have it turn right. But again, if the last thing the robot reads is not bot.stop, it's just going to keep doing the last thing it read. So you got to have add a bot.stop. So you can go ahead and upload this and play with it. For a little bit, why don't you just try uploading different programs to your robot? And I would suggest adding back bot.stop at the bottom to make sure that it actually stops. But go ahead and play with different different orders of commands and just get a feel for driving around. Now, one thing I should note, I'm going to go and delete some of that stuff that I did. You'll notice a few things in your program. The first is this mess up here. What this is doing is including the MOREbot library, which is what allows the Arduino to understand what bot.setup and bot.forward means. Next is we're setting up the robot, so we're creating a robot object, and it's not important you understand what that is exactly this moment, just that you don't delete this line. And you'll notice right here it says 1 and 4. Those are the motor ports that we're using. So the left motor is motor 1, or port 1, and the right motor is port 4. In the setup, this bot.setup is kind of like, think about it like jump-starting the robot. Not super important that you understand what this does right now, just that it's there. So you'll notice there's this void setup and void loop. All of the code inside setup is going to run just once. So it's like reading a recipe once and then putting it away. It's going to read these lines, and then it's going to stop. Anything inside void loop is just going to run forever. It's just going to keep, as soon as it gets down to the bottom, it's going to start at the top. So when you're wanting your robot to drive a very specific pattern, it's definitely best to keep your code in the setup. What's important is that you don't delete this curly bracket, because the program is going to complain. It's going to be really confused. It's expecting that and it's not there, so you need to make sure to add that back. And any code that you want to run in the setup has to be between this curly bracket and this curly bracket. So if you write your code out here, it's going to complain. See? So make sure your code's inside there or inside the loop. Yeah, so with that, have fun. Again, please stop your robot if it's going to hit something. And here are all the commands that you can start playing with. Make sure that you keep all of the syntax the same. You can't forget the dot. You can't forget the semicolon. And have fun.